Hi RDS users, in this video I'm just going to go through some of the basic functions of RDS Analyst, how to import a data set, a few things you can do with it, and then how to save your work. This will be a pretty introductory light video. I won't go too deeply into any of the functions, but there are additional help pages on any of the dialogues in the program, and there'll also be more detailed videos about specific functions. Okay, so I've installed RDS Analyst, and I'm just going to open it up from the desktop. The console window here opens first. All my required packages are loading. And then I see a data viewer here where data sets will be viewed. So at the moment I don't have any data sets loaded. So I don't see any data sets here. But that's the first thing we're going to do is import a data set. So I have to click on the console, and I'll see all these menus only when the console is clicked. Sometimes I'll call this being in focus. Now the console is in focus. Now the data viewer is in focus. So a file with the console in focus, I'll import RDS data. So I already have an RDS data set that I'm going to work with. It might not be saved in that same exact location all the way through for you, but if you just search for this X data file, or if you're using a Mac, I'm doing this on Windows, but if you're using a Mac, just search for the X data file, and you should be able to find the NYJAZ RDSAT file, which is the native RDS format. So I'm going to open that. I see the command that has just been called to the program, which is read the RDSAT file. And now I see this data in the data viewer. If I had multiple data sets loaded, I could select RDS New York Jazz from this data set list, but at the moment this is my only data set. Sometimes this just won't see your new data set automatically. If that's a problem, just close the data viewer and then just go back to packages of data and open the window again. Sometimes that is necessary just to refresh the list. Okay, so I have my data set open. Notice a few tabs on the data viewer. So for example, I have ID here, network size, coupon 1, 2, 3, 4. Then in variable view, I see those variables listed, as well as the type of variable that they are. So something that was names or words, although it's ID numbers here, but we don't actually care about what number they are. We only care about them as identifiers. Those are going to be listed as characters. Similarly, the coupons are treated as characters. And I'm actually going to change gender to be a factor as opposed to a numeric variable. So in general, categorical variables, you want to store those as factors. So for degree and then for airplay as well. So then once I do that, I see the factor levels here. And for example, in union, 1 would correspond to yes, and 2 is going to correspond to no. And that's just how the data was coded. So you can go into RDS. This is where you can edit factors about the data set itself. So specifically, RDS data, if it's in this format, it has variables listed for ID, recruiter ID, and network size. You can, if these aren't read in correctly off the bat, you can change them. Just click on the arrow, click what the variable should be, and enter it. We also have these optional fields, the maximum number of coupons. In this case, it's 7, which means that any respondent in the survey was able to recruit up to 7 more people for this survey. You can also enter population estimates. The mid one is the one that would be used as a default. I'm going to enter 20,000, and that might be used as a default value in future calculations, which you'll see. But in general, this won't be too sensitive. The functions won't be too sensitive to this value unless the sample is a large fraction of the population value. And just closing it will actually save all of those changes. So now that you've seen the basics of your data in the data viewer, you can look more specifically at the sampling process by plotting a recruitment tree. I'm going to leave all of the plotting options blank as their defaults, except for node label size, which I'll change to 0.8, and then run. Here's my recruitment tree for this sample. So what this represents is a number of trees, each of which is headed by what's called a seed, or someone who initiated part of the sample. Those were the original respondents. And then they just started to recruit their connections in the target population, in this case, the New York Jazz musician population. Since I didn't overwrite the default for the nodes, they're all the same color and size, but they're labeled for the subject IDs. So closing this, I could just play around with that a little bit, and instead I could use whether they are unionized as the node color. For example, I could also use the network size for the node size. And then I get some more information in my recruitment tree. So I see a legend here, unionized yes or no depending on color. And I also see where the most connected members of my sample were by the size of their node. So that's a basic recruitment tree. You can also do recruitment diagnostic plots. So I just saw a recruitment tree, so I'm going to unselect that, but I am going to select these other four and put this into a PDF report. And I'm not going to stratify by something, but I could. For now, I just want to keep it simple. So in Windows, I see this separate page launching with my PDF plots for recruitment diagnostics. So if I zoom out, I can see all four of these plots on one page. In the network size by wave plot on the top left, I can see that network sizes of about 100 are the most common, especially in the early waves. In the recruits by wave plot in the bottom left shows that the largest number of recruits came in the second wave and followed by the third wave, and then it steadily drops off. The top right plot shows the recruits per seed for each of the 14 seeds, and that captures the whole part of the tree that comes from the seed. Whereas the bottom right plot, the recruits per subject, shows how many subjects each individual recruited, and 1 is definitely the most common. So now that we've seen the data, sample data as a recruitment tree and seen the diagnostics for the recruitment process, we can start to do a little bit of inference about the population. The population crosstabs dialog in the population menu will allow us to make contingency tables of some characteristics that we're interested in, giving the joint and marginal distributions. So, for example, I can take airplay as the row variable and race as the column variable, and I can also put multiple row and column variables, and that would just give me multiple tables. I also won't stratify by anything to start with, and I'll leave the weight type as Giles SS. And there's more information about the different weight types in the Compute Weights help page. And for that, we'll also need to put in a population size, so let's go back to 20,000 and click Run. And we get a table. Yours might look slightly different from this. Specifically, these fields should be rounded in the newest version. But this is the general idea, basically a table of marginal and joint distributions. And it's important to remember that there could be a lot of uncertainty in these estimates, and we'll cover that more when we talk about the frequency estimate dialog. Let's try one more table, population crosstabs. And now let's stratify by union. Leave everything else the same and run. And now we have our old table here and our two new tables. If we want to just see those new tables, go back to element view and we'll see only those. So we see the contingency table for union being 1, or members of the union, and for union equals 2 for those people out of the union. Now if we want to make inferences that also show the uncertainty in our estimates, let's go back to population and go to frequency estimates. So this is a big feature of the RDS analyst software and of RDS analysis in general. So let's suppose here we're interested in the percentage of the population of jazz musicians that have received airplay. So that's our variable. We'll keep the confidence interval we're going to use at 95%, the bootstraps at 500. This will just give you the number of samples you'll be using to estimate that confidence interval. And if you haven't seen that before, it's not has something to do with the number of samples or units in your data. It has to do with the estimation process. And again, we'll leave the weights as trials. There's some more description in the help pages comparing these different weight types. And enter population size, 20,000. We'll leave these plots out for now. Those should be covered in another video. And we'll click run. This is going to be one of the more computationally intensive calculations, so it could take a minute or a few minutes depending on your data and your computer. Okay, now this calculation is done. I've just jumped ahead here just a bit. We see the output table here. We're in element view again, so we only see this one table. And we have point estimates. But in addition to that frequency estimate, we also get a confidence interval, so 95% confidence interval, 66 to 84%. This design effect is also worth noting. This tells us that the size of the RDS sample that we need has to be 2.87 times bigger than a similar simple random sample to get the same kind of power as that simple random sample. And then we have standard error and sample size for the valid data in our data set. If this sample size is smaller than the total sample size, it's probably due to missing data. Okay, so that's been a general overview of the kinds of things that RDS analysts can do. Now we might want to save all this work that we've done. So to save the data set, we might have made some modifications to it. In this case, we didn't. So we probably wouldn't need to save a new version, but if we did, go to File and Export RDS Data, and we want to save this as an RDS data set. That's New York Jazz data, press OK. And so we want to save it to the desktop. I already have one version saved there, so I'm going to call this New York Jazz 2 and save. And press OK. And then just to make sure that's there, if I went to File, Import RDS Data, the folder I just saved that in is automatically appears, and I see New York Jazz 2 is saved. Cancel that. Then the last thing is you might want to save, in addition to the data set, you might want to save the output tables and the commands that you've used in your session. Let's go to File, Save, click on the desktop. Let's call this console 1, save. So here's another example of a console I had saved, and I just have it opened. I saved it as a .txt file, and I have it opened here in just TextEdit, a simple text editor program. And you can see console command entries as well as contingency tables I created, so, and well as some frequency estimates are here too. So that's all for this video. I hope that was a good introduction to RDS Analyst. There's a lot more help on the help pages as well as other help videos, so that should get you started. Thank you.